Thank you so much. Just a reminder to all the speakers, the upcoming speakers, please speak in English. Because this conference is aired to international audience, besides, of course, the Egyptian audience, but mainly the international audience. So it is forbidden to speak in Arabic, so kindly speak in English, okay? This is just for the upcoming speakers in this event. Thank you so much. So, in our exploration of the realms of artificial intelligence and data innovation, it is imperative to delve into cutting-edge methodologies driving transformative advancements. Today, we are privileged to have a distinguished expert in the field to guide us through the intricacies of leveraging scene graphs for generative AI and innovative data products. Please join me in extending a warm welcome to Mohammad Essam. Mr. Mohammad Essam, the Senior AI Researcher at Nahdet Misr Digital Solutions, as he presents his technical talk titled Leveraging Scene Graphs for Generative AI and Innovative Data Products. And please be seated to welcome our next speaker. Thank you so much.
Good evening, everyone. I'm Mohammad Essam, Senior AI Researcher at Nahdet Misr Digital Solutions. Also, I'm a master student at Faculty of Computer and Information Sciences, Ain Shams University. Today, I will be speaking about how we can leverage scene graphs for generative AI. So today, I will be speaking about how to leverage scene graphs for generative AI and innovative data products. Okay, let's start with our agenda today. So we'll begin with introduction to scene graphs, some basic introduction for the scene graphs, then moving to the intersection of scene graphs with generative AI and how we can utilize scene graphs in some generative AI tasks. Finally, we will go through some real case studies that we can appoint or take advantage of scene graphs in it. So, okay. We have generative artificial intelligence. We know that generative artificial intelligence or generative AI is about how we can generate, whether it's text, image, or videos. That's happened because of prompting. We have a user, the user enters some prompt. So, for example, when we use ChatGPT, the user enters some text, and then the model take the text and answer with generated text. Okay? So, generative AI is based on the prompt, on what the prompt the user will provide. So, the question here, is it the best way to provide the model with our data, with our modality, with images, with videos, with text, or if there another type or another data type that we can provide for the model, where the model can enhance or have a better understanding of what we are trying to tell him. Actually, there is another type of data, which is graphs. Graphs is better for AI models. It's proved theoretically that AI models learn better from graphs. So one of the types of graphs that we can construct is scene graphs. The concept of scene graphs basically has been used in computer graphics to adjust the scene, like we'll see here. So actually we have example here. I don't think you see the table. There's a table here. Actually, so actually there's a table here. So we have a vase. The vase has flowers in it, right? And there's a pear here, right? Actually, so our idea basically is to take this image and pass it to an AI model that will construct the above graph. So the idea, I'm not trying to pass the image itself to AI. No, I will use an AI model first to construct this graph, and then pass the following graph to the following AI models, whether it's generative or AI models, whatever. So what's the main idea of using a graph? Why using a graph? Using a graph will make the model understand better our context, understand better what's the object in the image or in the scene, in our scene. What's the relationships between them? And that's very important. That's what really matters. When we pass a simple image, we just throw some pixel values, right? We are throwing some pixel values, or some, if we are trying to pass some text, for example, we are passing some unstructured data to the model. Is it better, or is passing some structured sort of data is better? It's much better to pass something like that, right? So the concept of seeing graph is a mix of graph theory, computational geometry, and computer vision. Okay. What's the applications that seeing graph served in? In computer vision, seeing graph has major advancement in very complex tasks, like 3D scene understanding, visual question answering, and cross-modal retrieval. So let's begin with 3D scene understanding. What's 3D scene? Anyone know 3D scene? Three-dimensional scene. The idea of the 3D scene is like I am in this room. I will scan the room with a camera and then transform this room into a 3D model, like this house. So what kind of applications I can apply on something like that? This is very, very informative in tasks like autonomous navigation. If I have a robot, a house cleaning robot, for example, that will be moving around the house, right? So I need a detailed view of the map of the house, right? So seeing graphs helps in building such models in 3D understanding. Okay, the next application we have visual question answering. I know most of you know the question answering, like I'm talking to ChatGPT, what's the capital of Egypt? Then the answer Cairo, right? But visual question answering depends on image and the question based on the image. Like in this funny example here, we have a girl that wearing a mustache of bananas. So I give the model two inputs, the image and the question. What is the mustache made of? And the model should answer. The model answered with bananas. Okay? So seeing graphs can enter here, transform this image into graph, transform the text into graph, and then try to answer based on these graphs. Last application in computer vision is cross-modal retrieval. So what's cross-modal retrieval? The main idea of cross-modal retrieval, like the search engines, like we enter Google, I'm trying to write Andrew NG in Google query. I will get text, right? I will get hyperlinks. I will get images. If I tapped on images, I will get images, right? So the idea of cross-modal retrieval is if I give a query, text query, I will get an image. I will get an image from my database. Like here, the user query here is baseball fields in a green environment. So the result from the search engine is the image with this caption. The image that has this caption. Cross-modal retrieval do it vice versa. So I can use text to retrieve images, and I can use images to retrieve text. Like the second example here, where we get a view of first terminal, where some yachts and boats are stands there. So I give the model the image, and then I get the caption. Okay. Right. Next, we move to generative AI. The first application is image generation. Have anyone here tried image generation? Okay, good. How many of you found some irrelevant results or non-logical results? Like a man with 9 fingers in one hand, maybe, or a man with 7 hands, arms, and so on. Okay? So the idea of utilizing scene graphs here is for conditioning the image generation, for applying extra logical conditions. So our example here highlight some critical case where I need to generate an image of a landscape, urban landscape, but with some condition. What's the condition? My condition here is dependent on the daytime and the weather. I want to generate this background in daytime, okay, at sunny weather. So I have the light distribution here in the image is balanced. So scene graphs can help us apply more and more logical conditions on the generation of images. Second task is video generation. Have anyone tried video generation? Actually, there's some tools online for video generation. It's not quite well yet, but unless Sura for OpenAI is the best one there. But I'm talking about some extra level. Imagine training the students of Faculty of Medicine on applying surgeries in virtual reality, like in this example. We have a doctor, the doctor working on knee surgery. The idea here is I have some physical condition for the knee, right? When you try to work with the medical equipments, you have to be careful or you will cut something or like that. So all these conditions should be applied to the video that I will see in the virtual reality. So scene graphs here make it much easier to apply these conditions. Okay. Next is the customized or personalized media. What's personalized media? Personalized media is the dream of any content creation company. Any company that has content, they want to apply the personalized media approach, where I have a set of limited content, but this content is distributed for every user in a way that each user like it. I know your interests, I know your preferences, then I will customize the content you see. So I have more and more user engagement on my platform, right? Actually, this idea has been utilized in NVIDIA Freestyle. Here in the screenshot, that's a video. So the idea here is for what? It's for game development. Their idea is to apply the idea of personalized media in game development. So how can we do that? Actually, they utilized some technologies like scene graphs. So you have customized game environment. So each one of us will play the game, will have his own environment. The environment that's more from his choices in the game, maybe, or or a survey before even starting the game. For example, I like green environments, then I will play in the middle environment here. Someone else like more dark environments will play in the dark environment and so on. So making the games more customized, so achieving better and better results. Okay. Let's move to the data products. We need some solutions for real life examples. Let's begin from retail. Scene graphs has major role in retail analytics. In actually two aspects. Aspect number one, imagine that I have this area here with no furniture. I have an empty area. And I want to open my own store. What I will need first, I need the best possible customization for product. I need to maximize the usage of area. Right? That's called optimizing store layouts. We are trying to optimize the store layout based on the given area and the given products, product shelves and so on, right? So scene graphs can take the scene graph of the place and then try to apply the operations to achieve the best possible optimized store layout. That's the first aspect. Second aspect is trying to analyze customer behavior. For example, in some countries like USA, Canada, and so on, they adding a camera around some products to analyze how the users or how the customers interact with it. Like I have a customer that takes the product from the shelf, look at it, and put it back. Or I have another customer, takes the product, investigate it for like 10 to 20 seconds, and then see the price and put it back on the shelf. So I'm trying here to what? I'm trying to analyze the customer behavior. Why the customer took the product and why the customer buys the product. If he buy it. If he not buy, why he doesn't buy our product? Is there some substance in the product itself? Or is the price is not compatible with this customer? Second case is security systems or surveillance systems. Like we have in retail, we have multiple cameras. Each camera will cover some space. So I want all of this information in one unified graph. Based on this, we can detect any threats, like some customer is stealing or some customer is taking out a gun or something like that. Okay? So the idea here is to have the input from multiple cameras to work with single graph. Okay, our next case is intelligent traffic management system. Okay, how can we apply intelligent traffic management system? Actually, there are major studies in this area. Why? Because we have many traffic elements, right? I have autonomous cars, I have manual cars, I have bikes, pedestrians, I have traffic signs, right?